We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, today I am going to discuss about the 3 to 1 principle of location. You have a subject tool engineering in the 6th semester. The subject code is 3361902. In that chapter number 3, locating and clamping devices. So today I am going to discuss the 3 to 1 principle of location from this chapter. This 3 to 1 principle of location is very important as far as the exam is concerned. If you refer so many last question papers of the GTU, you will find these questions. This question is repeatedly asked in the GTU examination. So today we will understand what is the 3 to 1 principle of location. Before we start understanding the 3 to 1 principle, the chapter is the locating and the clamping devices. So first of all, it is very important to understand what is locating. So here you can see the definition of the locating, that is most important definition. What it says that locating refers to the dimensional and positional relationship between the workpiece and the cutting tool. This is the most important definition of the locating. So once it is understood, then we can understand the locator. Now what is locator? It is the device to establish this relationship and maintain the position of the part in a jig or fixture to ensure the repeatability of the worker. So locator is most important whenever the worker is loading the workpiece in the jig or fixture. This locator is very useful, and that's why it is written over here to ensure the repeatability of the worker. Now these are some basic rules which I have listed. The basic rules for the locating. First one is the positioning of the locator, accuracy and tolerance, foolproofing, duplicate location, and motion economy. Let us understand the principle of location, 3 to 1 principle. For that, I have taken this figure. You can see this rectangle block. It is the workpiece, and we can assume that this workpiece is in the space. Here you can see the 3 axes. Axis x-axis. Okay, you can see this axis x-axis. This axis y-axis, y, and the vertical axis z. So here this workpiece, this rectangular workpiece is having 3 axes, x, y, and z, and we can say that this workpiece may move in either of the 2 opposed directions, okay, along all these 3 mutual perpendicular axes. It can move in either of the 2 opposed directions, and all these movements, right, all these movements are called movement of translation. So let us see what are the movement of translation. We will understand. Let us consider first the x-axis. So here we can say that this workpiece can translate to this side, okay, and this may move to this side also. So along the x-axis, the workpiece can translate in either side. Here the movement numbers are given. This movement is given number 9, and opposite side movement is given number 12. Similarly, if you consider y-axis, okay, so the workpiece can translate along this axis from both the side, left side as well as on right side. So another 2 translatory movement. Here right side movement is given the number 10 and this left side translatory movement is given number 8, right? Now let us consider this z-axis. So workpiece can move upside and workpiece can move downside also. The downside number is given 5 and upside number is given 11. So all these are the 6 movement which are called the movement of translation. Now second thing, the workpiece can rotate in either of two opposite direction around each axis, clockwise and anti-clockwise, right? And these 6 movement are called rotational movement. So let us understand these 6 rotational movement. Let us consider this x-axis. Okay, now along this x-axis the workpiece can rotate in clockwise or in anti-clockwise in both the direction, right? So now 2 rotational movement about x-axis, and these 2 movement are given the number 1 and number 2. Similarly, if I take y-axis, so along the y-axis the workpiece can rotate in both the direction, clockwise and anti-clockwise, and you can see over here these 2 movements are given the number 3 and 4. 3 and 4. Similarly, along y-axis the job can rotate, workpiece can rotate in both the direction, clockwise and anti-clockwise, and the numbers are given over here. You can see it is a motion number 6 and 7. So the sum of all these 2 types of movement, 2 types of means movement of translation and rotational movement. So we have 6 movement of translation and 6 rotational movement. If you sum all these movements, it will give you 12 degree of freedom of the workpiece in the space. Okay, 12 degree of freedom, right? Now as far as the principle of location is concerned, all this movement of the workpiece, okay, the movement of the workpiece in any of the 12 degree of freedom, that must be restricted. So now let us see in the next slide how this degree of freedom should be restricted. Now you can see this figure over here. These are the 3 views. You can see this one is the fixed body. You can see the fixed body, this L shape, right? Here you can see that rectangle workpiece. Okay, the same top view is shown over here. The top view of this figure is shown over here, and this one is the side view, right? Now the workpiece is resting on 3 pins. You can see over here the 3 pins over which the workpiece is resting. This pin A, this pin B, and pin C. These 3 pins that you can see in the plan also. This one is your A, this one is the C, and this one is the B, which are shown with the dotted line, right? So over this 3 pin our rectangle workpiece is resting, right? Now the object cannot rotate about the axis XX and YY. Okay, about these 2 axes XX and YY, now the object or workpiece cannot rotate, and also it cannot move downward. You can see over here because of this 3 pin the workpiece cannot move downward. In this way total 5 degree of freedom, total 5 degree of freedom, number 1, 2, 3, 4 and 5 have been arrested, or you can say restricted, right? If I providing this 3 pin A, B, C, so we can restrict this motion 5 degree of freedom, 1, 2, 3, 4, 5, right? Now second, if we are adding 2 more pins, pin number D and E, that you can see in the plan. In elevation you can see only this E pin, but beside that E pin we have a pin D also. So another 2 pin and the side wall are inserted, right? You can see that P, D and E, which are inserted in the plane which is perpendicular to the plane. This plane which is perpendicular to the plane containing the pin A, B, C, right? We can see over here this plane is perpendicular to this horizontal plane which is containing 3 pin A, B, C. Now object cannot rotate about the z axis. If we are providing this D and E, so you can see that object is not, okay, cannot rotate about the z axis, and the object cannot move towards left. Here we can see now this rectangle object cannot move towards the left because of this 2 pin, right? Thus we can say that pin number D and pin number E restrict 3 more degree of freedom, right? 3 more degree of freedom. And which are these degree of freedom? 3, number 6, 7 and 8, right? Now in the side view you can see pin F. Pin F in the second vertical plane, this one is the second vertical plane, which restrict degree of freedom number 9, right? So another degree of freedom that is restricted by this pin. So we can understand by providing this A, B, C, D, E and F how many degree of freedom we can restrict. So here we can see is number 1, 2, 3, 4, 5 restricted by providing pin ABC. Then number 6, 7, 8 which are restricted by providing pin D and E, and number 9 which can be restricted by providing pin F. Go ahead. This 3 degree of freedom remaining 10, 11 and 12 are still free. Okay, this 10, 11 and 12 are still free. These 3 degree of freedom are not restricted by this pin A, B, C, D, E and F. So to restrict this 3 degree of freedom, 3 more pins are required for this each movement, right? To restrict the 10, to restrict 11 and to restrict 12. We require 3 more pins, okay, to stop this movement. But this will completely enclose the workpiece. If we are providing to restrict this 3 degree of freedom, we can understand that this will completely enclose the workpiece. And thus, what will happen? The loading and unloading of the workpiece into the jig and the fixture, it will become impossible. Okay, if we are restricting all these remaining 3, so the loading and unloading of the workpiece in jig and fixture, that will becomes impossible. So remaining this 3 degree of freedom may be restricted by means of clamping device only, right? So this is most important. So what we require to provide the clamping device. So remaining 3 degree can be restricted by means of the clamping device. Finally, we can say this principle is called 3-to-1 principle. This 3 pin, here this 2 pin and this 1 pin. So it is called 3-to-1 principle, or it is also called 6-point location principle also. I hope you understand this theory. If you have any doubt, you may please ask me. Okay, thank you.